Hi there, this is Kieran Oversapian again for Filmstorm, and welcome back to our fourth part where we're going to have a look at how to create and set up the character blueprint. Now, we covered this to begin with in our second part where we looked at how to do the first project with the motion matching plugin, but now we're actually going to dive a bit deeper and have a look at each node and how everything runs. So to start off with, we've got our third-person character blueprint open. Let's just go up to Edit and let's go to Project Settings, and here we are in Input. So what we want to do is let's just have a quick look at what we have set up. We have a sprint, our jump, crouch, aim, our move forward axis, our move right axis, our look up, and our look right. Now these are all pretty much standard ones, apart from these ones. These are the custom. So our sprint is just set up to left shift, jump is space, crouch is C, and aim is right mouse button, and of course the complementary ones for the controller. So let's just close that out, and let's come over to get rotation and position for goal. This is our first macro, so you can come over to your macro and click new, and then dive into it. And if you go to your last output, you can actually create two new parameters, and both of them should be transforms, and you'll want to set them to be input direction transform and world transform, and then that's where we're going to plug our return values that we calculate in. So here we are. Let's just pop that down there so we can follow this a bit easier. Okay, so beginning, we have get control rotation. So basically we're just getting the rotation from our controls. We're going to break it, we're going to grab the Z yaw, and we're going to make a new rotator, and we're splitting that again between our two vectors. We're getting a get forward vector and our get right vector, and we're timesing that by our two values. And in this case we're getting our forward and we're timesing that by 1.5 just to give it an extra boost forward. And then we're plussing them together, and we're going to times this by our direction input strength, so how much direction we're actually pushing. In this case we have 400. And then we are grabbing our get world transform of our mesh. This is our mesh up here for our player. Move that a bit too far. And then we're going to break this, and we're grabbing the location and we're plussing that with our control rotation that we've broken. And then we're plussing that again with our other rotation, and then that's how we calculate our input direction transform. And our world transform is just our mesh is world transform, so we're just plugging that straight into world transform. But this really simple calculation is how we calculate the directional input from our controller. Now of course you could switch this around, you could do custom calculations. So say you're climbing a ladder, you just have to calculate the up and down axis and then just plug that into your direction transform. And of course you can have many macros running, you can have different driving different prediction datas. So you can have this called ground prediction data, you can have climbing prediction data. So basically it could be pushing up and down, left and right, do whatever you want. Basically that's just how it drives the motion matching. So let's jump out of this one. Let's go down the node, and here we are. We have create motion matching input data. This is probably the most important node for what we're doing because this is how it calculates everything. So let's jump in here. We have our two inputs. So we continue our execution line. We have our desired transform and our root world transform. And then we also have on our output, we have our world transform and our input transform. And then we're continuing our execution line. So here we have our desired transform, or desired target, sorry. And we are still timesing that by our input strength of 400. We have our desired transform and our root world transform, and we plug them together. And it chucks out a data structure, which is our root prediction data structure. And we're going to set that. And basically that is what we're going to take over into our animation blueprint, and that's what drives the motion matching node. And for debugging purposes, we are going to break that root prediction data. We're going to break that struct. We're grabbing every last index, and we're getting that, and we're going to put that into a transform. We're going to compose those transforms between our mesh, and we're going to break that, and we're going to put that in here. So we have our world transform again of our mesh, and we have our input transform from our route prediction data, which is technically the last index every time of that in that array. So that's what we're showing in here. So that flows through to our debugging. So our debugging is basically showing two lines. We've got our main line. So if we bring up our editor, you can see, if you pay attention to the floor, we have our trail and we have our directional input. So our directional input, the line behind us is just starting from our current world transform of our player, and that's just going to drag behind us, and then this line is basically which way we're actually going to start moving. So this is our input direction line, and then we just have two helper scripts strings here. And then let's follow this up. So basically we're going to follow the execution line up into our rotation helper, and this rotation helper macro is our calculate rotation. Now essentially this one is basically whenever we are pressing the forward, right, left, whichever direction you're going, and we release it on that very last frame, we're gonna basically capture that, and we're gonna be setting the rotation to that. So you can see we're setting it really quickly here at 400, and then back we're not really doing much here. So if we have a look at our other rotation helper, our stop detector, how we're doing this is we're getting the input forward and we're getting the input right, and we're basically then comparing that to a delta rotator. So we're grabbing the rotation, so we know the rotation between the capsule and the follow camera, so that way we can calculate which way the player is actually looking inside the world. And we're breaking that, we're getting delta rotator of both, and also our input. So we're grabbing the delta rotator between the camera and the capsule, and then we're grabbing the delta rotator between the capsule and our input. So that way you get a really accurate input direction. And we're breaking that, we're grabbing the Z, which is basically you could think of, if you look top down, that's the way you rotate it. And we're setting that rotation, and we're going to branch it, and we're going to do it once. Now basically what drives this branch to do it once is when we release the button. So say we're grabbing the clamped value of both input forward and input right, so that's either forward, back, left or right, and we're plussing that together with an absolute value, which is only going to ever be 1 because we're clamping that. So no matter which way you're pushing, it's only ever going to be 1. And then if we're saying that's less than 0.1, which means you've obviously released the input, we're going to say this is going to be allowed to be true because that's technically true. We're going to do it once, and our do it once is our finished rotation. We're getting just that capsule components rotation, and that is it. So basically that is our finished rotation that we take over into our finished rotation, and see how it sets it really quickly. So it's, as soon as we press up, we release the keys or the joystick, it's saying okay, that's the finished rotation, and we're going to interp straight to that so our player doesn't rotate off in some weird direction, because that's one of the downsides to motion matching. It's also grabbing all of the rotations from that motion matching data as well. So this is a good way to counteract that. And then once it's done, we're basically just going back to our normal world rotation. So that is how that works. And then we have our normal inputs. So as you remember from our input screen from our project settings, we had our sprint, which is just a simple boolean set over here. Yes or no, are we sprinting? Jumping, this is basically from every single project. So if we're falling, and we're not jumping. It's very self-explanatory. We've got our crouching, yes or no, and our aim handler, yes or no, and just our simple rotation for our camera. So input axis look up is going to be our pitch, and our look right or look left is our yaw. And that is an overview of our motion matching system inside the blueprint. So thank you for watching this part. In our next part, we're going to have a look at how to take that over into our animation blueprint.